Have you ever wondered how the internet works? How you're able to send and receive messages within seconds across the globe? Well, behind the scenes, there is a world-leading system in place called the OSI Model, and that's what we'll be discussing today on the channel IT with G. Whether you're into computer engineering, networking, or any field of computer science, or you're just curious about how the internet works, just stick around to the end of the video, because once you understand this, you are going to appreciate how the internet works very much. The OSI model is a conceptual framework which is basically used to understand and implement how network communication works. It was introduced in the early days of the 1980s and has been around for some time now. The OSI model is structured into 7 layers: the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer. To best understand this, we are going to tackle it from the physical layer right to the top. Starting with the physical layer. The physical layer, just as the name implies, deals with the physical transmission of raw bits, that's zeros and ones, over a physical medium. This could be either electric signals which run through UTP cables using Ethernet connections, or it could be fiber optic cables which carry light waves, or even radio waves, which is the technology Wi-Fi's do use. So, in the physical layer, all we're basically talking about is how the data actually travels from one device to another. Right above this layer is the data link layer. The data link layer is responsible for node-to-node data transfer and error correction or detection. What we mean here is the data link layer is responsible for carrying data from one device to another within the same local area network. It ensures that data packets are delivered to the correct device on the same local network. This is where MAC addresses are being used. These MAC addresses helps the routers to identify the devices on the network. The MAC addresses helps for intra-communication, that is communication within the local area network. So when a device A wants to send a message to a device B, it uses the MAC address. Data in this layer is called a frame, and before a message or before the data leaves one device to another, it is associated a source MAC address and a destination MAC address, which tells the data frame where it is leaving and where it is going. That is what the data link is about, responsible for intra-communication within the same local area network. We could think of the data link layer as a truck driver who delivers goods to houses with house numbers within a city. They don't travel outside of the city. So, in the case of networking, what if we want to send data across to another network? That is when the network layer comes in. This layer is responsible for logical addressing, routing, and the best path determination for the data packets across multiple networks. A data packet is what we call the data in this layer of the model. So, logical addressing is just IP addressing. This layer gives the data packet a source IP address and also a destination IP address, just to tell the data packet where it is leaving and where it should go. It is also responsible for routing, which is directing the data packet as to where to go and also determining the best path possible for it to use. That is what this networking layer is about. One key networking device being used in this layer is a router, and what a router basically does is it serves as a gateway for the local area network to communicate with multiple networks. We can think of this network layer as a GPS system which works in, say, an Uber. So you pick an Uber going to the shopping mall. The driver turns on his computer in the car, and then it shows it where you are going and also the best route to take to get there in time. That is what the network layer does. Now, with the destination being known and also the routes to take being known, it is the transport layer that does the transportation of the data to where it is supposed to go. This layer is responsible for segmentation of the data into smaller chunks for transmission. What it does here is it divides the data into smaller bits and pieces to be transferred over the bigger network onto the receiver. It is also responsible for flow control, which helps it to prevent overwhelming the receiver of the message. It helps to determine the best rate at which the data is to flow to make the communication a success between the two devices. It is also responsible for error control, which detects and corrects errors when they occur during the communication process. These errors can be in a form when the data packet is lost during transmission. In this case, the transport layer retransmits the data according to the protocol being used. Some of the major protocols being used in this layer is the Transmission Control Protocol, the TCP, or the User Datagram Protocol, the UDP. These protocols are used in data communication, with the TCP being connection oriented, which means it relies on a connection to be established between the two communication devices before data communication or transfer takes place, and so it makes it a reliable form of delivery. In the case of the UDP, it does not rely on a successful connection. It prioritizes the speed of delivery over the reliability of the delivery, and this makes it a best choice for online streaming purposes. In conclusion, the transport layer is responsible for making sure the transfer of data is complete and is done in the right order. Now, after data has been transferred, the session layer takes over. This layer establishes a session, which is a connection between the two communication applications on the devices that are taking part in the data transfer process. It also manages the session and also terminates the session after the data transfer or communication is complete. One major role this layer performs is synchronization, which is setting up checkpoints in the data stream so that in case a failure occurs, the communication process can resume from the last checkpoint instead of starting all over again. So, this layer is responsible for establishing, managing, and terminating the connection between the two applications on the devices taking place in the communication process. Right above the session layer is the presentation layer. It presents the data to the application layer. This presentation process includes processes like encryption and decryption, compression and decompression, and data translation. The data that has been coming all along may be in a form that the application layer won't understand. So what this layer does is it translates the data into a form that the application that is doing the communication will understand. It also handles some important aspects of data protection like encryption, which is important after a session has been established to encrypt, which is basically to protect the format of the data that is coming in during the communication process. The topmost layer, which is the last layer, is the application layer. This is the layer that provides network services directly to end-user applications like browsers, email clients, or file transfer programs. This layer also defines some protocols which are for application-specific communication purposes like HTTP or HTTPS, which is used in our web browsers, FTP, which is for file transfer protocol. When we are emailing, we also use the secure mail transfer protocols. That is what the application layer does. They help with the application we use. So as users, this is the layer we interact with. From web browsing to emailing to live streaming, this is the layer where we live as end users. So, we've now uncovered how data leaves our devices as raw bits, which are zeros and ones, travel with MAC addresses, which helps them with intra-communication, that is communication within our same local area networks. When this data is to be sent to another network, that is when the network layer comes in. This is where IP addresses are attached to our data frames and they become data packets. They are given the best path where they are to travel, and then the transport layer takes over, helps with the actual transportation, make sure the data is received completely and in order. The session layer then comes in, establishes a session to help ensure that our communication between the devices continue taking place. The presentation layer now makes sense of whatever that is coming in during the communication process. That is encrypting and decrypting the message, translating the message into a form that the applications do understand. And then the application layers provide the interface where we communicate with as end users. There you have it. Layer by layer, we've broken the internet down so you can build your knowledge up. If this video helped you to understand the OSI model and networking in general, please consider liking the video, sharing it, and also subscribing to the channel for more tech-related content. Drop a comment below if you want us to talk about the TCP/IP model, which is actually the practical way in which the internet works. That is just the beginning, so invite others and let's take this tech journey together. Until next time, stay curious and stay secure.